Okay, so let's take a look at this example right here. So Nestle claims that in their bag of mixed chocolates, there's 78% chance that a bag will have Kit Kats. If James buys 20 bags of mixed Nestle chocolates, what is the probability that, and then we've got some questions, okay? So first you need to recognize that this question here, right, is a binomial distribution type question, okay? So if we define our variable, so x is going to represent, basically you're getting a Kit Kat in the bag, right? Now the probability of this happening, they say, is 78%, right? So the probability of this happening is 78%. So we have x is binomially distributed. Our number of trials is going to be 20 because he buys 20 bags, and the probability of success of getting a Kit Kat is 0.78, right? Which is 78%, right? So you always want to state these parameters, right? So let the examiner know that you recognize this is a binomial distribution question, okay? So now in part A, we want to know what's the probability all the bags contain Kit Kats. Well, there's 20 bags, so that means that x is going to equal 20, okay? Now technically you can just calculate this out in the calculator now, right? But I want to write out what's really happening, right? Make sure you understand what's happening. So basically, if we were to expand this using the binomial distribution equation, right, we've got 20 number of trials, right? Success is 0.78, right? And then failure, 1 minus 0.78, right? So success is going to be all 20 bags. So this is going to be 20 here. This is going to be 0, right? Now on the calculator, when we use the calculator to calculate this, basically all you would have to do is menu, statistics, distribution, go to binomial. We're going to use a PDF because it's x equals. All right, our trials is 20, success 0.78. All right, x value is actually 20, all 20. Right, so we get 0.006948. So is approximately 0.006948. 0.006948. Right, 6948, correct. Okay, now I'm writing this out right here so that you guys understand what exactly has been calculated by the calculator. Basically, the calculator just calculated this, okay? And if you were to have to write this part A out in expanded form here using the binomial equation, this is what you would write, okay? Now, what you really need to do is, all you have to do is, once you have probability of x is equal to 20, right, you could just say that, well, I'm going to use binomial PDF, and then you put all the information in the calculator, which is going to be this. So we have, there's 20 number of trials, success probability is 0.78, and x value is equal to 20. And then we will get this answer right here, 0.006948. So for a question like this, you really don't need to write this. You can if you want, but you should write this right here to let the person know what you're typing in the calculator, what you're putting in the calculator, right? But I'm showing you guys this because, like I said before, on more challenging binomial distribution questions later, you will have to write this out in order to solve for the number of trials or something like that. Okay? Let's take a look at the next example here, part B. So part B, let me just erase this. So in part B, we want to know more than 18 bags are going to have Kit Kat, right? So more than 18. So the probability that x is going to be greater than 18. So more than 18 means we do not count 18. So we're talking about 19 and 20, okay? So this means that, well, what's the probability that x is equal to 19 plus the probability that x is equal to 20? So if we were to write it out, right, using the expansion, right, this would be 20 here, this would be 0.78, this would be 1 minus 0.78, and then this would be 19, this would be 19 here, this would have to be 1, right? And then over here, we were to expand this out, This is 20. This is 0.78. This is 1 minus 0.78. So this is 0, 20, 20. All right. Now, so when we're going to use the calculator moment to calculate this. So when we use a calculator using binomial, right, CDF, because it's an inequality. So this time we're going to use binomial, right, but it's going to be CDF because we have an inequality. So number of trials, 20. Success, 0.78. Lower bound, what's the lowest value x can be? Well, that will be 19 because we want x is greater than 18, right? And the highest it can be is 20 because 20 is the number of trials. Right, and we get 0.04614, all right, 0.0, so approximately 0.0, let me write it down here, 0.04614. And then let's actually write out what should binomial CDF, that's what we use. So we had 20, comma 0.78, lower bound was 19, upper bound was 20, and then our answer 0.04614. 0.04614. All right, so that would be the answer for part B. So once again, right, you actually don't need to write all this part right here. I'm just showing you guys what's really happening kind of behind the scenes in the calculator. So the calculator, when you put this in the calculator, it's calculating all this stuff, right? This is what it's calculating. Basically, it's saying what's the probability x is 19, what's the probability x is 20, and then it's adding that to get this answer right here. Okay? Let's do the last part here. So the probability less than 15 bags have Kit Kats. Okay, so once again, so the probability, all right, less than 15 have Kit Kats. Okay, so less than 15 actually means x could be 14, 13, 12, right, 11, 10, 9, 8, going all the way down to 0, right? So there's quite a lot of them, so I'm not going to write them all out. So, but you guys get the point. So now we're going to calculate. This is going to be a binomial CDF because we have an inequality, right? And then we have 20 for our number of trials. Success probability is 0.78. All right. Now our lower bound, what's the lowest value x can be, right? Well, the lowest value x can be is 0. The highest can be, if this is less than 15, the highest value x can be is 14. So we'll put this in the calculator. Menu, probability, distributions. We have a CDF. All right, number of trials is 20. Success, 0.78. Lower bound, all right, we have 0. And then upper bound, we have 14. Click OK. Then 0.26573, right? 0.26573. So we get 0.26573. Okay? 0.26573. 573. Okay?